to know, how long should an escalator be if it is to make an angle of 33 degrees with the floor and carry people a vertical distance of 21 feet between floors? So what would we do? Okay. We know, what's an escalator look like? Yeah, it's going to be the hypotenuse of the right triangle, right? It's this slanted side. We're trying to find how long that is. So that would be our x. The floor is horizontal. So that angle is 33 degrees. Carries people a vertical distance, so that's this side of 21 feet. So that would be a right angle. So how would we set this one up? So sine is opposite over hypotenuse, so the sine of 33 degrees is the opposite side, which is 21, over our hypotenuse, which is x. So then if we wanted to solve this, what would we have to do? So you need a calculator. Make sure you are in degree mode. So 21 divided by the sine of 33. If we rounded to significant digits, how many significant digits did we have in the problem? 2, so we would round this to 39 feet if I asked for significant digits. Questions? So we jumped around a little bit on our examples yesterday. I want to go ahead and do the example right after this one as well. So this says a man climbs 213 meters up the side of a pyramid. So what would that look like? That would be your hypotenuse. He's going up the pyramid. He climbed 213 meters. Alright, so I'm going to go ahead and draw this, my full pyramid here. Okay, the angle of depression. So this man is standing on the top of our pyramid right now. When I talk about an angle of elevation or depression, what do you have to have? A horizontal. So if he's at the top, we would draw in the horizontal at the top of this pyramid. The angle of depression goes from that horizontal down is 52.6. How high off the ground is he? So you could draw a couple different triangles, but probably the easiest would just be to look at that triangle right there. Because then we already have the angle in the triangle. We have one of the sides. This would be a right angle. If I'm looking for how high he is off the ground, I'm looking for my x here. So how could you set this one up? So 52.6 equals the opposite side, which is x, over the hypotenuse.
How'd you get sine again?
From this angle, this is the opposite side, and this is the hypotenuse. Yep, so circular. So 213 times the sine of 52.6. How many significant digits do we need? So we would call this 169 meters. So far, so good? I'd like to do, we'll go back to the first page, that third example. We skipped this one yesterday. So I guess it's the bottom of that first page. Marla needs to find the height of a building. So we have some building here. She wants to know how tall it is. From a given point on the ground, so it's on the ground here, the angle of elevation, so angle of elevation is measured from a horizontal up. So we have to draw in our horizontal and going up. That angle is 74.2 degrees. She then walks back 35 feet. So she's walking away from the building. So now she's over here. This distance was 35. From the second point, the angle of elevation to the top of the building, so going from that horizontal up to the top, it's 51.8 degrees. We have to find the height of the building. In order to use a trig function, what kind of triangle do we have to have? A right triangle. So we have, how many right triangles in this picture? 2 of them. We have this first one, and it's up to you if you draw this separate or not, but we knew that, we're trying to find x. Then we have the second one with the whole thing. Do we know what this length is right here? So I could call that maybe a y to begin with. What would be this length in the second triangle? Y plus 35. So we did one of these in the last section, and we didn't have any on the homework like yet, but we have to find x. So if I looked in this first triangle, x is opposite, y is adjacent. What trig function is that? Tangent. So the tangent of 74.2 degrees equals the opposite side x over the adjacent side y. So if we multiply the y over, but then I'm kind of stuck because I don't know x and I don't know y. So the second triangle, we could do something similar. X is opposite, y plus 35 is adjacent, so we could again say tangent trying to solve for y, we would multiply by the denominator. Take a second look at that. Let me know if I've lost anybody. Kind of got ugly in a hurry. What can we do now? These are both equal to x, right? So if they're equal to the same thing, they would have to be equal to each other. Now what? We have one equation. It has y's in it, so we need to get those on the same side. So all I did right there was subtract that term to the other side. Both of these have y in them, so what can we do? We're actually very, very close to the answer. I know it's long and ugly. These are equations that you solved in algebra. It just looks so much worse because we have trig functions in there as well. What would you have to do to get the y by itself now?
Can I see Joshua just a second?
Of course. Okay. So now it's a matter of putting this in the calculator. Keep in mind, every time you push a tangent button, it opens parentheses, so you have to close it. And then, good practice, make another set around the entire numerator and entire denominator. So let's plug that in. So that's y. What did I ask you to find in this one? X. I asked for the height, which is x, but that's actually really easy to find now. Because remember, we had right here that x is y times the tangent of 74.2. So we just have to take that answer times the tangent of 74.2 degrees. How many significant digits do we have in this problem? 3. So we would call it 69.5. Feet. So that is by far the longest problem we've done. We did, I think, 1 or 2 of those at the end of section 2.4. And so I thought we would bring up another one here just so we can talk about it again. Are there any questions? I think there is one other example I didn't work yesterday. We have one left. So the very next example, and then this will be my last one for today. So yesterday we focused more on those bearing examples, so I know a couple of you were gone, I need to catch you up on that. Today we're just focusing on reading these word problems, drawing pictures, and solving. So we have the two equal sides of an isosceles triangle are each 24 centimeters. What's an isosceles triangle? Okay. Is it a right triangle? No. So these are both 24. If each of the two equal angles measures 52 degrees, find the length of the base and the altitude. So the base is the bottom part here. Altitude is like your height. When you look at that height, what kind of angle would it form? So if I want to use a trig function, all we really have to do is take 1/2 of this. So if I wanted to find A, from this angle, A is the opposite, 24 is, so that would be sine. Multiply over 24. So if we go to significant digits, we only had 2 in the problem, so that would be 19 centimeters for the altitude. How would we find the base? Okay, we now have A, so we could do tangent. We could use the 24 and do cosine. But B is the entire thing. So we first just need to find that part of it in our right triangle, so let's do that as X. I'll use the 24 just because that was an original number. That way, I like to use the original numbers whenever I can, so if I'd made a mistake, it wouldn't mess up everything. But it really doesn't matter. So that would be the cosine of 52 equals my adjacent side X over my hypotenuse 24. So if we multiply your 24 over so the base, what would you have to do to that number? Yep, multiply by 2. And if we round to 2 significant digits, we get 29.55, so that would be 30 centimeters. So really the main thing you have to remember, if you are going to use a trig function, you have to have a right triangle. So I couldn't use the entire thing, I had to take just half of it there. Questions? So yesterday I gave you guys